Hello everyone and welcome back to our series of Learning to Code with B5. Today in this video, we will try to create our very own clock using some of the time functions that exist in Pre5 already. And we will also combine them with some of our previously learned concepts of variables, mapping, transformations, and of course, loops. So let's get started. All right, so first things first, make sure that you've already remixed your project and given it a name before you start off with your new exercise. As today we are going to be creating our own clock, there are a few things that we will be playing around with. We're going to stick to mostly working with a single shape, which is rect. And that's how we will end up creating some of the tick marks, which is basically all the way from 1 to 12. And then we will also need to create handles, right? So that they determine hour versus seconds and minutes. All right, so let's start with something very basic, which is basically giving a color to our background. We will fill our rectangles with whites. So let's just do this. And also perhaps maybe a no stroke. Okay, once we have done that, if let's say we are trying to create a rectangle here at the center, we know that we need to first translate, right? And then we will create our rect. So starting off with something simple. Half of width, half of height, there we have, and then 0, 0. We can look at how big or small we want it to be. So width, too small, and then height, maybe we can keep 4, too thin. Okay, maybe we want it to be a bit longer. These are all for tick marks that we are starting off with first. So I'm going to move this one basically under here. Why? Because we're not going to be creating single tick marks. We need at least 12, right? Going from 1 to all the way to 12. Again, if we want to have 12 of them, we do not need to create them one by one. We can actually make use of our for loop. That's what we will do. And just quickly to tell you, we are starting it off here, but then we are going to spread them out as a bigger clock so that we have 1, 2, 3, all the way 6, 9, and then 12. Okay, so we're going to put our for loop. Within our for loop, we are going to move it inside. Kind of really jumped at the top. Okay, again, what is the syntax of our for loop? Again, we are starting our index with 0. I is less than num. We can actually create num here. Let num is 12. Although we won't be changing it, but it's okay to keep it flexible. And then I++, right? So all we are saying is that we need to create 12 tick marks in this one, and you're going to show that to us. So first of all, why has it stopped appearing? I'm going to just refresh it. Okay, I don't know, my glitch is acting up a little bit. So okay, now it seems all right. So now what we have is basically we've created 12 of these rectangles, but these are all on top of each other. So technically we don't see them, like we can't tell them apart. What we need to do is, because we need it to be created in a circular format, we will try to rotate each of these tick marks first, so that, you know, we can kind of start getting the structure of our clock here. And the way we are trying to first rotate is that we need to have some sort of an angle, right? Because we are trying to rotate it within a circle framework, right? Our clock right now is in a circle. For that, we can already understand is that we will need to rotate it, and then we need to have a certain kind of an angle that can be put inside. So literally just, let's say, call it angle, and then we can create another variable called angle, and then we can map it. So the way we are trying to map, of course, because I've used it here, an incomplete thing, so you can't see it anymore. But the tick marks are going to be spread out within a certain sort of size of the circle that we're going to determine, and that's what we're going to map it to. So let's say, again, coming back to our map function, it again needs 5 parameters. We are going to map each of the tick mark, right? So that means that we are going to use index as our input value here, right? And then from 0 all the way to 12, or num here, I am going to map it from angle 0 of the circle all the way to 360 degrees, right? That's the entire circle, basically. So saying it here, and again, I need to put it in an angle format, so you can literally either call it radians, and then within it you can put 360, or forget the disjointed kind of a rotation, but I'll get to that one in a second. Or you can use the pi format of writing things, and you can call it 2 pi. Okay, so if you remember, pi is basically 180 degrees, right? 2 into pi is basically 360. This is a specific syntax where you need to write it in all caps. That's the way P5 understands. So just be mindful of how you kind of write it here. Okay, coming back to why it feels like it's kind of rotated, like first of all, we can't see all 12 of them, and they are kind of like in all weird places. The thing is, if we remember that our rotation and our translations, all of those things are cumulative. And since we have put this within our for loop, so within each iteration, what's happening is it creates the first tick, right? And then it rotates, and then the second one, and rotates and everything. So all of these have become too much accumulated. If we want to make sure that each of the tick is working independently and is not being calculated from the previous one, we can use, or we can make use of these amazing push and pop functions that can help us sandwich everything in between. So now we have all these tick marks basically spread out in a circular format. Okay, that looks kind of cool, but what is something that we need to kind of look at here is if we try and see here. Okay, so we are going to spread them out. Think of it like going from 12, 3, 6, 9. But these are not in a very orderly position where we would like to see in our clock, right? So 12 and 6, they are not aligned, so are 3 and 9 are not. And also, the reason that we can think of it is, first of all, we have mapped all the tick marks between 0 and 360. If we remember from our from how we have been working with circles within P5, is that they start from this side, right? So the 0 starts from here, 8 not from here, and it goes all the way 0 to 360. So if we start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, what's happening is that it is taking all the way from 0 to 360 here, and it's not evenly. We needed to stop one before 360. One before, I mean, a certain angle before 360. So if we start from 3 o'clock, we need to end it till 12, so that we can see all the 12 angles here. So 2, 4, 6, 8, 10, 12 here. Okay, right? So what we will try and do here is we are going to, okay, first of all, one more thing that I want to make sure of is, okay, let us align this first. This is a little bit below right now. Why? Because the 0 point for any kind of rectangle is at the top left corner, right? So we want it to be a little bit in the center on the y-axis. So since our height is 4, we can offset it by -2. So let me just see if this kind of works. Okay, right? So 3, 9, 6, 12, 1, 2, 1, 2, 1, 2, 1, 2. Okay, that kind of works. All right, so what we will try and do next is try to push them out so that, you know, they can be a bigger circle. And the way we need to do that is we need to translate, because we have already translated it to the center. We need to push them out so that 1 can be here, 2 can be here, 3 here, all the way 6, and then 9, and then 12. And the way we will do is we're going to add another translate here. And how we will try and translate this one is that we are going to create another angle. Not an angle, sorry. We are going to, on the x-axis, we are going to use a certain size to determine the size of the circle. So let's just create another variable called radius, because that way it will determine from the center to the edge of the circle. So let's say with, I don't know, divided by 3, and use this radius to determine the translate function. Okay, so now you can see that we already have 1, 2, 1, 2, and then they are all kind of apart. So if I just pause this one for a second. Okay, this looks okay. Let's try to do this here. And then you can kind of make it bigger or smaller. If you don't want to use height, or if you want to use, if you don't want to use width, you can also use height. You know, that way it will, because when we are resizing the window, we are technically resizing the width mostly. So if you want to keep it a little bit more consistent, you can use height as well. So that's up to you. All right, so now we have our tick marks already spread out, 12 of them. We will try to now create our our handles for our second minutes and our. How can we do that? First of all, there's something which is super easy that P5 already knows, and those are basically the time and date functions. So if you go to their reference page, you will see that there is day, hour, minute, month, second, year. All of these, what they're doing is basically pulling up the information of your calendar, including the date and time, and using it basically for us. So we don't need to write a whole function for it to, let's say, read the clock within our computer. So that's one thing, or online, right? The other thing is that, well, basically from your computer. The other thing is that there is another one called millis. This is different from this second, because the second is basically the second handle. Millis is used for a timer. So let's say if at any given point in time in your code, you're trying to calculate some kind of time using a timer, right? So starting from 0, 1, 2, 3, 4, 5 seconds or whatever, that's how it calculates. But instead of in seconds, it calculates the time in milliseconds. So that one is slightly different, but the day, hour, minute, month, and etc. are basically all our time and calendar. We will today be making use of our minute and second. Okay, so I'm gonna start off. Oh, one more thing before I kind of jump on that. This translate and rotate, it is important for you to remember how they are kind of, which one is preceding which one. Because if I put translate on top of rotate, so it will first translate the whole of this group of tick marks and then move it around. Whereas if I am rotating it first, that means that each of them will first be rotated and then translated to a certain position, which is why we can actually see them being spread out and at different sort of like locations, instead of just rotating from one origin point, the whole cluster of tick marks. So the order is sort of important, and I just wanted to make a note of that. Anywho, moving on, what I am going to do here is we're going to start off with our hour handle. So let's make use, let me in fact copy this. So if we have a rect here, remember we already have this translated at the center of the canvas. So anything that I'm doing below is basically starting off from there, but I can change this one to be a bit thicker. And I'm going to make sure that we are already offsetting it because we are using the same sort of format. So this is going to be an hour handle. It's a bit small. Let's just, okay, too long. I think we can do that. Okay, and then, okay, why are we seeing all of this being created here? So remember, this is because starting from 0 all the way 360. So that's where the starting position is. For our rect, this is going to be a helpful thing to remember. I'm just going to start and rotate the angle for it. That's how it will start sort of calculating. For that, what we need to do is, of course, we need to rotate, use the rotate function, within which we will put some kind of an angle, and I'm going to use an R angle. R angle, and that means that I am going to use this as a variable. Okay, so what exactly, how are we going to determine what an R angle is? And for that, we are going to, again, use our map function. So what we are mapping here in this one is that we want that the way R is being calculated from our machine, and I want it to be mapped to our entire circle so that it can move from, you know, all the way from 1 to 12, and it can kind of keep moving the handle. So the input value is going to be the one that we have just seen in our reference page. So we don't need to calculate how it's picking up the hour clock, hour from the clock. And then we are going to use that as an input value. Of course, the minimum is starting from 0 all the way 12, because of course we have 12, sort of 1, 2, 3, 4. And then we are going to map it from 0 to 360-degree angle, right? So again, I'm going to use this, and I'm going to say 2_pi, so that it's telling 0 to 360. So that has sort of shifted. But the thing here is, this one is basically starting from this 3 o'clock and not from a 12 o'clock sort of position, right? Which is basically in our real world, that's how we sort of calculate. So what we need to do is basically we need to move our handle from this position first to 12 o'clock, so that, you know, it can start the calculation of the whole clock starting from 12 and all the way there. Otherwise, when in our real world we are calculating, let's say 6 o'clock, it will already be at 9, right? Because we are not sort of aligned, our circles are not aligned. So what we need to do is that, let's say, if it was this, right, we need to actually shift it back here. So we already know that this is 360, right? 2 pi. We need to shift it 90 degrees angle. And what we can do is, pi is basically 180 already. So we can minus 90 degree by using pi divided by 2. Right? So that way, when we are actually doing this, it will actually give us the exact hour on our clock as well, which is basically the time that we can see on our computer. All right, otherwise it would be almost like 3 hours sort of off what your clock is going to be. So that is one thing. And of course, this is the same thing that we will have to do for our minutes and handles as well. Again, all of these rotates and everything become cumulative. So we are going to make sure that we are keeping all of these handles independent, and I'm going to put them in push and pop. And I'm going to copy this and make our lives a bit easier. Again, we are gonna be doing this for our minute. And I'm going to use this here as well because there's already a minute function as well that it is picking up the input. Instead of 12 here, I need to do it 60. Why? Because we have 60 minutes. And the rest stays the same in terms of how it needs to be mapped, because the circle thing remains the same. And here I'm going to use this minute angle as our for our rotation. And then here, of course, I can make changes to however I want the rect to look like. So maybe we can make it a bit, I'm going to keep the offset as well, half of, whatever height that I'm giving. And since it's a bit small, so maybe we can make it a bit longer. They don't look very, okay, maybe I can make it a bit here and then I can use this. Okay, so I think now they look a bit more different. All right, so now we have our minute handle. We'll do the same for our second as well. And I'm going to replace this. And I'm going to replace the second function as well. We don't need to change it here because 60 seconds in a minute, so that stays the same. But we have to make sure that we're using the right angle. And we can make it a bit more thinner so that it looks like a second angle handle. And so, yeah, it seems like this is already functioning. It's kind of showing you the clock or the time at the time of this recording. So great, it seems like it's all working. So I'll let you practice this one and I'll see you in the next video.